So today we are going to learn about the product rule. So up until this point, we have done we can do derivatives of constant multipliers like y equals 4x squared, right? We just multiply the exponent by the coefficient in the front and we get 8x. So that's a constant multiplier rule, right? So when we do the derivative, let's say h of x is equal to f of x plus g of x, right? Then we know that this derivative is just the sum of their derivatives. So it's f prime of x plus g prime of x. Now we've done some activities in class already, and we've shown that if h of x, or well, in this case I'll use t, if h of t is f of t times g of t, that this is not equal to f prime of t times g prime of t, right? So when it's multiplication, it's not just the derivative times the derivative, right? So if it's addition or subtraction, then we can do the derivative plus or minus the other derivative. But when it's a product, that is different, okay? And so I have up here f and g. So this is an example for it. So let me just show you that that doesn't work, right? So if I do f prime of t, here's my f of t up here, then that would be 4t. And if I do g prime of t, so here's my g of t, then that would be 3t squared plus 4. So if it were this, then the derivative of, or h prime of t, would be equal to 4t times 3t squared plus 4, which would give us really 12t cubed plus 16t. Okay, now there's a way to check this because these are just two polynomials, so I could actually just multiply them together first. So let's do it that way. So let's do f times g. So that would just be 2t squared times t cubed plus 4t. I'm sorry if you hear my dog growling in the background. There's probably some person on the street which he's having a breakdown over, but I really don't have any place else to record, so I guess you're stuck with me. Okay, so I have this. If I multiply it together, I would get 2t to the fifth plus 8t cubed. I'm distributing here, okay? And now I can do the derivative of this, so I'm going to call this h of t. So the derivative h prime of t, then, now I've turned it into just like a sum here, would be 10t to the fourth plus 24t cubed, which is not the same, right, as what that was. So we just took the derivative of each one and multiplied them together, but that is not the actual derivative. So this does not work, right? It doesn't work. So the product rule is, right, so if we have some function h of t, and we have f of t times g of t, then the product rule is h prime of t is f of t times g prime of t, and then plus, then the reverse. So I did the derivative of g in this case. Oops, sorry about that. Let's see. Trying to get used to my camera again. Okay, so f of t times g of t, the derivative is f of t times g prime of t plus f prime of t times g of t. Okay, so basically it's the derivative of one in each pairing. Now, right, I can write this in any order I want. I could write this as g prime times f. I could write this as g times f prime. I could write this one first and this one second because it's plus and multiplication and they're both commutative. So there's lots of ways I could write it, but basically the general rule of thumb is there's one that's plain times the derivative of the other, and then plus then the opposite. You do the derivative of the one that you didn't do in the first part times the plain one, okay? All right, so let's just use this. So let's say I have something interesting here. Let's say we have q of t is equal to z cubed times cosine. Oops, actually, let's do q of z, cosine of z. So if I'm going to use this in this particular case, I'm going to write it out kind of formally here. I'll say that my f of z is z cubed, right? And my g of z is cosine of z. So one way to do this is to actually do the separate derivatives, like write it like this and find the derivative of each one. So f prime of z would be 3z squared, and g prime of z would be negative sine of z. So then that would mean that essentially what my product rule is going to have is basically this times this plus this times this. Okay. So that would mean that q prime of z would be, if I write this one first, z cubed, and then minus sine of z, so I'm going to put the minus in the front here, and then sine of z, and then I have plus, then the opposite is 3z squared times cosine of z. Okay? So let's do another one. Let's say I have h of x is equal to, let's see, we'll do 2 to the x times 3 cosine of x. Okay. Now another way, you can call, like, it doesn't matter which one is which, right? I can call one of these f and one of these g and do it just like I did up here and write the derivatives separately. Another way that I often teach students is to actually just write this out twice. So I write it out twice, and with a plus between it, because I know my product rule is plus 3 cosine of x. And then I make a little notation. So I'm going to do the derivative of this one in this part, and I'm going to do then, since I did that one in that part, I'm going to do the derivative in that part. So this is me saying I still need to do the derivative, but this will be what my product rule will look like. So now I'm just going to do the derivative of each part and drop it in. So I know that the derivative of 2 to a power, right, I have a number to a power. This is an exponential, so it's 2 to the x, ln2, and then times 3 cosine of x, and then plus, this time I'll just have 2 to the x, and the derivative of cosine is negative sine, so this will be then times minus 3 sine of x. So maybe I would probably like pull this minus sign out and write it here so it would be minus, but this is perfectly fine as well. Okay. Let me do one more example. So what if I have, let's say I have my f of x is equal to x squared plus x times 2 to the x. Okay, so I'm going to say that this is one of my functions, right, because it's multiplication, and this is the other one. So I'm going to use this method where I'm going to write it out twice. So my f prime of x will be, I'm going to write x squared plus x, since I'm going to do the derivative of that one first. It doesn't matter which one you do the derivative of first, as long as you do the derivative of the opposite one in the other part. And then that times 2 to the x, and then I have plus x squared plus x times 2 to the x, and this time I'll do the derivative of that one. Okay, so my f prime of x would be, so this time I'm doing the derivative of this one. So the derivative of this is x squared plus x is 2x, and then plus 1. These need parentheses because there's two things in them, times playing 2 to the x because I did the derivative of this one. And then I have plus x squared plus x, not doing anything to that, doing the derivative of 2 to the x, which is 2 to the x ln 2. And that's my derivative. With these, I really don't think you need to simplify them. There are ways to simplify them often, but I wouldn't. I mean, unless it's really complicated and you're trying to put in a number and you're thinking, wait, I don't know if I can, I would just leave it as it is. You do not need to simplify these in any way. Okay, so let's take this one step farther. Okay, so I know that I just did, this is my f, right? So what if I want to use, what if I wanted f prime of 1 in this particular case, right? So in this case, if I didn't already do the derivative, I would need to do the derivative, but this is my derivative. And so then f prime of 1 just means I'm going to plug in 1 everywhere here, right? So that would give me 2 times 1, which is 2, plus 1. So I'm going to have 2 plus 1 in here. And then times 2 to the first, so that's times 2. Plus then 1 squared plus 1, so that would be plus 2 times 2 to the first, which is 2, times ln 2. So my f prime of 1 then would be, let's see, I have 3 times 2 plus 4 ln 2. So basically I have 6 plus 4 ln 2. Okay? And that's really all I can do with it. Now if I was going to write the equation of the tangent line, right, then this would be my slope. And if I was going to do that, then I would need to, if this was going to be my slope, when I put my m in here, I would need to put parentheses around it. So it would look like this, right? This would be the right-hand side, 6 plus 4 ln 2 times, and then it was x minus 1. I didn't figure out what y was. I mean, I could do that. So if I wanted to write the entire equation, then this is the slope, this is x minus 1, and then I would need to plug in 1 to come back in over here to my f. So f of 1 in this case would be, I'd plug it in here, that would be 1 plus 1 is 2 times 2 to the first, which would be 2. So actually my point would be 1, 4. So this would be 1 minus, or y minus 4. So that was if I would take it one step further. This one I was just finding the derivative at that point, which is also the slope of the tangent line at that point, right, which we knew was that x minus equals 1, so then it ends up being x minus 1. And then I went back to f and figured out what the y coordinate was to write the rest of it. So this would be the equation of the tangent line to that curve at 1.